All right, we'll go ahead and get started here. Thanks everybody for joining in today for this live webinar. We'll be doing some SF6 gas analysis with the Flex and doing a live training on best practices and how to use the Flex, some of the features and benefits of the Flex itself. And then at the end, we'll have time for live Q&A. If you do have questions throughout the meeting, you can put them in the chat box. And Justin will get those answered as the meeting goes along. And like I said, at the end, we'll have some time to kind of go over those. All right. So, howdy everybody. My name is Luke Benden, Vice President with GasQuip. And like I said, today we're going to show you guys some of the features and benefits of the Flex and talk about best practices while testing gas. So first off, let's talk about the setup. So whether you have our Flex analyzer or you have a different analyzer, most of them are built into a Pelican case like this. So you want to open this up, and inside of this compartment here will be a sample hose, the gas sample hose, and then also a power cord. And we've already got our device plugged in, so we'll just leave that in there. So once you have that plugged in, either to 120 or 240, you'll turn the device on, press this power button on the top, and get it powered on. So let's talk about the physical layout of the analyzer with some terms that I'll be loosely throwing around throughout. So you have down here, these are adapter fittings. So if you pull this out, this is an adapter fitting that'll snap on to the end of our sample hose and can connect up to a gas circuit breaker that might have a port for a DN20 or a DN8 style adapter fitting. Up here you have our sensor module manifold. So we have 3 sensors that sit in a module like this. And the reason that we did that is so that when it's time to have your device calibrated, you no longer have to send it back to us. We basically just send you a replacement sensor module. You pop out the old one with a little torque wrench, pull that out, pop in the new one, kind of like a printer cartridge, and you're good to go. All the calibration data is stored on the module itself, and it'll pull up on the device automatically. Never have to send the device back to us. Fingers crossed. So that is this area over here. Obviously, we have 2 communication ports up here at the top, a USB port with a, right now I have the mouse plugged in so we can do stuff on the computer. And over here, underneath this, is a storage bag for internal storage, about the size of a football, and can store up to 2 to 3 measurements depending on which measurements you're doing at that time. At the front of the device, you have a sample hose port where we'll plug in our sample hose. And then you have an auxiliary storage for when you want to plug in a gas recovery bag to store additional measurements, maybe up to 15 or 20 measurements at a time if you need to do multiple tests. And that is kind of the physical layout of the device. And we can now talk about the operation and show you kind of what the analyzer looks like up close. So like I mentioned, this is the up close live feed of the analyzer. Hopefully you guys can see my mouse okay. This is what the device looks like whenever you turn it on. So I'll kind of go over the different areas. Here in this big area, you have the different sensor modules that will be plugged in at that time. So up in the top left, you have the units. The top right, you have the name of the sensor module. In this instance, it's the SO2. And then it'll say selected. And if you deselect that, it'll say select to use. So you can turn on and off different sensors for whatever test that you want to run. Up here in these black buttons and down here are the functions that we'll talk about later. This over here on the right is an area for the input pressure. And down here is the storage percentage for the internal storage, which is also linked to the auxiliary storage if you do have a gas recovery bag hooked up. Right here is the play button for whenever you need to start a test. Up here is the settings button to go into your settings, and we'll talk about that later. So let's run a test, and I'll kind of walk you through what it looks like to run a test on a bottle of gas. Real quick, Justin, if you don't mind, can you just verify that I'm coming through and that everything looks okay before I get too far into this?
Yeah, you're good. We can see the mouse on the screen and the touch panel as you're operating it. So all good on this side.
Wonderful. Okay, so like I mentioned, we've got our sample hose here that we will get plugged into our device. So what you do is you take the male end of the sample hose and clicks right into this sample hose port like that. We'll run this down here. And we'll go back to our analyzer. And what we're going to do first is pull a evacuation on that sample hose to remove any residual gas that we had from previous tests, or maybe there's some moisture in there that we need to pull out. So we'll run an evacuate hose function up here in the top left, right here. It's going to say, are you sure you want to evacuate your hose? Please confirm that there is no vessel connected or you will pump all your gas to atmosphere. So we don't have anything connected yet. So we'll evacuate that hose. You can hear that vacuum pump kick on, and then we'll get a confirmation that the hose has been evacuated. And then we can also verify that if we click dismiss. Here in the input pressure, we now see a negative 12 PSI showing for the input pressure, telling us that we have evacuated our hose. So we can select and deselect the sensor modules that we want to test from. So we'll just leave those connected. Let me get back to scene here. So we've already connected up our regulator. This is a high pressure cylinder reading about 310 PSI currently. We've already connected up our cylinder regulator with our wrench, snugged it down. It's a CGA 590 connection, so it's opposite of a nitrogen, so it's righty loosey, lefty tighty. So we'll tighten that up. We've got a Rectus Type 21 male on this, and we can connect that right up to our sample hose. All you do is pull back the collar on that and just shove it on there. Now what we'll do is introduce gas into the line. And if you look at here, on the analyzer, the input pressure should jump up to whatever pressure we set here on our regulator. So we have our input pressure here on this gauge, and we'll increase the pressure going on the output by turning the knob clockwise like so. You need the pressure to be anywhere from 5 to 145 PSI. So we'll put it on 50, call that good. So if we go back to our analyzer, we got 47.456 or 56. Now we can run a test. We've got gas running through the line, everything's set up. We've selected all of the sensor modules that we need to run, and all we do is press play. So we'll have a live readout of the value that the sensor is currently measuring. And I can show you on the analyzer itself, might be kind of hard to see, but there's lights that light up as the sensor module is running to tell you that's currently running as well. So you have the live readout. So right now we're getting 0.0 parts per million of SO2 in this particular test. This in this accuracy, or this parentheses, is just a accuracy rating for the test itself. And we just put that in there as like a way for the user to understand that you may or may not be falling into the tolerance of the sensor itself. So for example, if you're testing a bottle of gas and say you have you know, 100 or 99.9% purity on this bottle of gas that you're testing, well, the accuracy of the sensor for the SF6 sensor is a plus or minus 0.5%, meaning that if you test that bottle of gas and you get a 99.5% readout on that, you know that you're within that tolerance or accuracy of the sensor, and you know that your gas is passing your spec or meets what you thought it was going to meet. So this button right here is just to hide the live results of the test if you'd like to do that. And then for the individual readout on the H2O, you can change the units for this as well. So right now we have it hooked up, or right now we have it defaulted to dew point atmosphere Celsius, and it'll show that accuracy in the parentheses in that same units as well. Down here we have the time remaining. So the first test of the day will run for about 12 minutes. And then subsequent tests will run for about 7. So this test, I've already run a test for today, so this test is only going to run about 7 minutes in total. The reason that the first test runs, let me go back to the scene here. The reason that the first test runs a little bit longer is that in our H2O sensor is built in a heater to the tip of the sensor, and that heater helps to burn off residual moisture that's left over from storing the analyzer and just general moisture that builds up or tends to build up inside the device. And that's unique to us. That's the first time it's been done in an analyzer. The reason that we did that is that if you've been out in the field testing gas, you notice sometimes that it takes 2, maybe 3 tests before your values really start to hone in and get where you need to go, especially on the moisture. So heating up that sensor to burn off that residual moisture is acting as a way to not have to run 2 to 3 samples to pass gas over that and desiccate out the sensors. You can just heat it up and start from a clean slate. So as the tests are completed, you'll see down here we have a below, for the SO2 module, we have a below 12.0 ppm. That is a user set test limit, and we have in there a defaulted value for each sensor module. So for SO2, there's a threshold in there for anything above 12 ppm SO2, it'll flag it. This whole module will turn red instead of green and tell you, hey, you didn't pass your tests, you didn't pass your, it could be utility standard that you have for, say, purity, like on this, we have it set to 97% SF6. That could be customized to whatever you need to work off of, depending on where you're at and what you're testing. But it's just another way for the technicians to understand right away, hey, we passed the test or we didn't. Didn't talk about this yet. So this enable auto pump back is a feature that if you click it to enable, so we just enabled that, it'll run in the background. And by run, I mean the pump back will pump the gas that it just tested or anything else that's inside, that's stored inside the device. It'll pump that gas back out through the sample hose port out to the breaker that you're testing kind of in the background as you look through the results. The thing about PumpBack is you cannot use PumpBack on a high pressure cylinder. Our compressor inside the device only pumps back up to 145 PSI. So for instance, even if we had this directly hooked up to the cylinder, you still wouldn't be able to overcome that pressure to pump it back. Let me go back to this thing. You wouldn't be able to overcome that pressure to pump it back into the cylinder. It's also limited to because we have a regulator that has a check valve on it, so you're not going to be able to push back against that anyway. But just so you understand, you can hook up an empty cylinder directly without the regulator directly to an empty cylinder and pump that gas to be stored just at a low pressure. Many people do that. They call it a pony bottle just to store the gas from the device. That works as well. So you see our storage has started to go up here, and this will kind of dynamically fill up with the white as each of these goes up. If at any point during the test you need to abort or pause the test, you press this button here, it'll take you back to the main screen and kind of abort all the functions. All right, so here is the results screen for running a test. Obviously, we have our SO2, SF6, and H2O like we talked about earlier. And it's the same setup that we had mentioned with the units, with the accuracy of the sensor itself, and then that user set test limit that we talked about earlier. So all of our tests passed on what we had set for the threshold. So anything above 97% for this, anything below -39, and below meaning drier as you go lower in dew point. So all of these passed. If you would like to rename the test name, which is up here, it defaults to the date and time at which it was run, and then it has the serial number for the device. You can rename the test here and just input that. Excuse me. And then also you can put the user location or any additional notes in these areas. You just click on that and it pops up in the keyboard, and you would just hit save here to save any additional notes that you need. You can either delete this test up here with this trash can icon or save it. So if we save this test, it'll ask us, or say log successfully saved, would you like to pump back? Now, like I mentioned, we can't pump back into this cylinder because it's a high pressure cylinder. So we're going to keep that gas in the internal storage for now and say no. And it takes us back to the main screen. Excuse me. Now let's talk about some of the functions. So like I mentioned earlier, we've already run the evacuate hose function. The evacuate bag function is, say you're running nitrogen through the device to flush it out, and you have a device full of nitrogen. You can just flush that out of the device to ambient air with the evac bag function. Leak check, this would be a vacuum pull on all of the internal components. Let me go back to the scene. So it pulls a vacuum on all the internal modules, plumbing, and it'll hold that vacuum for 30 seconds to see if any vacuum rise happens inside the system. And if it does, then you know you have a leak, which could be causing some of the issues that you're seeing if you're getting high or low readings, depending on which module you're talking about. We also have the pump back, so you can pump back directly from the screen, from the main screen, and the dry system. So the dry system is nice in case you are experiencing high H2O levels. Most people are either instructed to use like a nitrogen dry out, which works great, but we built this new dry system function into our device. So what happens is, go back to here. The H2O sensor will run that heater for 5 minutes, and then you'll have the vacuum pump also pull a vacuum on all of the internal sensors, modules, plumbing, and that helps to kind of start from a clean slate like we talked about earlier, pulling all that moisture out of the device that might have seeped in, or if it's just been stored or whatever. It's a good way to kind of start from a clean slate and dry everything out. So that's all of those functions. Now we can look at our log. So for the test that we just ran, if we go into our log, which again, let me go back to the main screen. This is settings down here at log. We have our log files. So we have our name of our test that we did earlier. We can click into this button here, and it shows us that same result screen. And we can also adjust any of the data that we need to in this screen, or go in and delete it, or whatever you need to do. So that's the log area. As you kind of fill up this with multiple log files, you can export that with a USB stick. So all you would do is take your trusty USB stick, which I don't have on me right now, but it would plug in where this mouse is plugged in right now. Plug it into there, and you go back onto your analyzer, click export, and it would export that file directly onto that USB stick. That file is a CSV or text file that just has all of the raw data, readouts, date, time, everything that you need that you've inputted onto the test, and it'll export it onto that USB drive per each individual log. The system settings, here we have a setting for an external bag, so we can check and uncheck that. Actually should have had that unchecked. I forgot to uncheck that, but you can check and uncheck this for whenever you plug in an external bag. And you can also change the capacity based on the amount of liters of gas the bag can hold. We have ours defaulted to 52 liters here because our bag that we have is a 52-liter bag. So that will also change the percentage of storage that'll show up on the main screen like we talked about. Date and time, and then we have units. So temperature, pressure, the H2O units here we can change to ppmv if we'd rather have that, which a lot of people do. SF6 carrier gas, this is a way for you to test mixed gas breakers, especially in a lot of cold environments. They have mixed gas breakers that have CF4 inside of the breakers. So if we go back to our main screen, you'll see now that, where'd my mouse go? There it is. Our SF6/CF4 option here, and it'll spit out a result that has the breakdown of 60% SF6, 40% CF4 as that goes along. Something else I should point out here: the storage now jumped up to 33% because we don't have that external storage telling the system that we have external storage hooked up. So we'll leave that disabled, and obviously the language area there. So user settings, just for advanced settings for us to run diagnostics. Don't have to worry about that. Modules. So we have the sensor module data stored on each individual sensor, and you can have the information for the cal date, expiration date, the version, the serial number, and you can just click through the list of different sensor modules here. Like I said, as you remove and replace the sensor modules, this data is automatically auto-filled to this menu, so you can go in and see which sensor module might need to be calibrated and which one is still good. This test limits area is what we talked about earlier with setting those thresholds for the test to either be pass or fail. The SO2 limit, SF6 limit, and H2O limit are all a little different. So SO2 is anything above 12 ppm for a maximum amount of SO2 you can have. SF6 is a minimum. So generally speaking, you want to have at least a minimum amount of purity of gas. And then H2O is a limit of how much moisture you can have in the system. And like we said earlier, the drier you get, the lower into the negatives you go with a H2O reading. So you can go in there and change that. Just click on it and input whatever value you want. But those are the default values. Okay. We can talk about calibration for a sec, and I'll do a little demo of how to do that. So if we go into our bag up top here, we got our torque wrench. So basically we would send you whatever sensor module is due to be replaced, and you would take your torque wrench and see this. Let's do this top one so you can see it. Take your torque wrench. There's two long bolts on either side of each sensor module. You're going to unscrew those like so. And pull that up like that, and it just slips out like this. You would take your new sensor module and plop that back in with the new calibration data on there. And all you do is just push that down and tighten these up. And then you take your torque wrench and tighten these down. And this is set to the predetermined torque that you need. So it'll click once you've reached the torque, and it won't let you tighten it or over tighten it once you're already bottomed out. So we got a click there and a click here like that. And that's all there is to it as far as the calibration goes for each of the sensor modules. Pretty quick and easy there. I should have mentioned on the analyzer itself, as you disconnect the modules, the sensor will say disconnected on here. So whenever I disconnected that, it said disconnected. Now it says selected. It's ready to go. All right. The calibration intervals that we have. So SO2 is every 1 year. SF6 is every 2 years. H2O is every 1 year. That is a manufacturer recommendation. You can push that as far as you'd like. If your device is still reading good, you're testing against calibrated gas and you're still getting good values, that's up to you, but that's what we recommend because the sensors tend to drift over time. So that's what we recommend as far as replacing those. I have some general troubleshooting tips here. I think we've already talked about some of those. So if you do run into some errors or some issues with your analyzer, it could be our analyzer, could be a different analyzer. First thing I would always do is turn it on and off. So unplug or turn it off, unplug it, plug it back in, turn it on, and then see if you can replicate the issue that you're having, whether it's just some bug or your readings are higher or lower. Sometimes that helps. Start with a clean slate. Check the firmware. So you can go into our settings, system, and then firmware version. Make sure that's the current firmware. You can give us a call or email us to see if there's any updated firmware that needs to be loaded onto the system. Really easy to update the firmware if you need to, or software if you need to. You just plug in a USB stick that has the file that we send you onto the USB stick, plug it into the device, and click update, and it would just automatically grab that file and restart the device with the new firmware. Past that, if you have high readings, if you're getting high readings on your H2O sensor, you can run that system dry out that we're talking about earlier. You can run a leak check to make sure you're not leaking. If you have SF6 readouts that you think are lower than expected, you can also run those two functions. And you can also take a SF6 leak detector, check your hose, check your connections on your front of your analyzer, check your connection on your cylinder to make sure you're not leaking anywhere. Sometimes the CGA connection can get boogered up and have a leak coming in from the cylinder connection if you're testing a bottle of gas. Those are just some general places to start before you start ripping the analyzer apart or something like that. So let's see here. I think that's about all I've got as far as the main, let's see, operation. Yep. So let's look at the chat, make sure we don't have any questions that need to be answered. And we can go from there. Justin, I haven't been looking at the chat or anything like that. So do you want to hop in on that? Let me grab a drink of water.
It's all clear, man. I was going to ask you, and this would be beneficial to everybody. The device runs the SO2 sensor or the SO2 test first. We have it set up to where if it exceeds a certain value, it stops the test and asks if you'd like to continue, or does it just stop? So I know it runs it first. Following or?
Sorry about that. I had myself muted. Yeah, if it sees too much SO2, it'll abort the test, and that's that user set test limit. So if it goes above that, it'll cancel the test because it don't want the SO2 to be running through the system.
Awesome. Okay, I just wanted to clarify that because that's a good safety feature for people to try to prevent damage to the device. It's something I had noted down to bring up when we had a break here.
Great.
I don't see any questions. If anybody has one, please feel free to type them in, or if you want to unmute for a second, just raise your hand before you do so we can make sure we don't have 10 people trying to talk at once.
I think they might have their mics blocked, so it'd probably be best to put it in the chat. I think
okay.
I might, here I can allow each person's mic as they raise their hand actually. So let's do that. Okay.
Okay, calibration of equipment just popped up. The calibration of the device is basically just hopping onto our site, ordering a module, and we send you guys a replacement, and you unscrew the old one, put the new one in, and you're done. It's meant to be kind of like a printer cartridge. Brad just popped up a question about the shelf life of the sensors. The only one that has a definitive shelf life, and this is applicable to all SO2 sensors, is the SO2 sensor. Obviously, it's an electrochemical sensor, and those have about a 6-month shelf life before the chemical's been activated. And then beyond that, you really want to start. It's a 6-month shelf life prior to activation. And then once you put it in, it just declines in a linear fashion, a certain percentage per month. some companies run them a little bit over a year. They'll still work, but if you start looking at the margin of error you have, it gets pretty significant. So that's why we've kind of recommended doing it a little more frequently, because it's not a super expensive sensor to change out, and it's a safety deal. But the others, there's not really a shelf life on those. Hopefully that covers the questions on that. We got a question about sensor costs. Luke, are you able to pop the internet up on the?
Yes, let me pull those up.
I can do a share screen, but I figured it might be a little better for me to not fool with it.
My Chrome browser's acting a little weird. If I remember correctly,
No problem.
the ones that are every year are 1320, so that's 1,320. And then the ones that are every 2 years are 2,640. So that is the cost of those.
Okay. So we have a question about the max operating ambient temperatures outside. Isn't it about 130 or it's pretty high. Do you know that off the top of your head, Luke?
I don't. I'd have to pull that up.
I have the manual if somebody can give me a sec. The other one, if you want to jump on, is asking about pricing. If you want to do that, I'm going to search the manual real quick for the other question.
Sure. Yeah. The pricing on this is standard at $25,000 for the standard unit that comes with the three sensor modules that you see here, the SO2, SF6, and H2O. Yeah, that's the standard price on that.
Okay, and then oh hey Doug, the pressures on the device, it's from about approximately 5 psi to 145 psi, and this is all gauge pressure for min and max pressures. That's for testing and for pumping, or pumping back is 145 as well, as Luke mentioned during the deal. So hopefully that covers that for you. The equipment can measure low pressure down to about 5 psi, and if this question's being asked about shipping breakers at shipping or testing breakers at shipping pressure, I'm going to just very bluntly tell you it's a complete waste of time. You'll get a reading. It's probably going to be garbage. You'll probably have low purity. You'll probably have wet gas. You have a very small percentage of the overall gas volume in there, and stuff's just not doing what it's supposed to. Yes, you can do it. It's not really a great thing to do. It's like I said, and this is my humble opinion, and I've had this discussion with a lot of other utilities, and it's a pretty large amount of us feel it's an absolute waste of time. But to answer the question, you can test down to about 5 psi to get valid reading. Sometimes you may have to run multiple tests because you have a very, very low gas flow for that, and it's hard to dry the sensors out and get flow through them. So again, not really something I'd suggest. Brad, yes, we can do parts per million by volume and parts per million by weight. You can do dew point at pressure, dew point at atmosphere, and I think Celsius and Fahrenheit, depending on what you like. Sorry, I'm still trying to find the temperature thing. I am getting distracted here. Anybody else has questions? Luke, is there an adder for CF4?
Is there additional cost for percent? Yes. Yeah. So this one has the CF4 option enabled on it, and that's 2,500 for the CF4 option to be enabled with that SF6 sensor kind of built in with it.
And is that, and I'm asking so I can remember as well, when they go to do a recalibration, the cost is to get the device set up for it. The sensor itself is going to be the same one no matter what, right?
That's correct.
Okay, so Doug, that's just an initial deal on the device because it's done mathematically versus having a special sensor for it, and that's the way I know you guys have used the Dilo units. There's a direct correlation between what volume percent you're reading and what it actually is if it's CF4. So it works off that same principle. Got a question: do we have a dew point sensor? Yes, that's the moisture sensor. You can just change how you want it to read, but moisture and dew point are used interchangeably with each other on the analyzer. It's what you're testing. It's just testing for moisture. Hopefully that answers that question from Drew there. Gosh. Okay, cool.
Yes, thanks. Okay.
Sorry, I'm still looking for temperature. We may have to circle back on that one if it's usually the standard range for electronics is what's listed on these devices. I don't see it on the manual offhand.
Tommy
Probably should
says,
put that
"What
in
is
there.
the Tommy says, "What is the max operating outside ambient temperature?" Oh, okay, that was already earlier. Sorry, I scrolled up.
Yeah, I unfortunately I don't see it on the manual. We probably need to add that. I would say safely because normally that's determined by the electronics themselves. It's usually what is it around 20 to 100 C or something like that. It's in those range.
Yeah, I've got it on that. I've got it listed, but I can't pull it up with my computer's overheating, running all this stuff. But
Nice.
we'll get that out to you, Tommy.
Um, I got a question from Josu about the, hold on, SO2 unit shows as ppm. Yeah, it is ppmv, Doug. Josu, I see you have a question about accuracy in regard to other equipment. Are you referring to how it compares to other analyzers? You want to just throw me a thumbs up or something on there? I'm hoping I'm answering correctly. If I'm not, again, jump on. The accuracy in comparison to others, this device is, if we're doing an apples to apples comparison, we would compare ourselves to the Dilo unit, the Wyka 3-in-1, the SMC 3-in-1. I'm probably leaving one out, but they're all similar devices to each other. The moisture sensors on all these devices are pretty much the same. One may use a slightly different technology, like ours has a heater versus theirs doesn't. But there's a breaking point on all the sensors. It's at about minus 40 C, which is I think it's at about 122 parts per million. Anything wetter than that, meaning you'll see a lower negative value, is plus or minus 2C. Once you get below that minus 40 threshold, it goes up to plus or minus 3, because if you start looking at a dew point chart, the values are much closer to each other as you get into the drier gases. So they've got a little bit more of a spread down there. And on the wetter ones, it's a little bit tighter because there's a lot of wiggle between those. So that would be the same for Dilo, Wyka, SMC, whoever else I left out. The purity sensors on all the devices where they use infrared, velocity of sound, they're all plus or minus a half a percent. So that's going to be basically the same for everybody. And the SO2 modules, even if you buy the most expensive analyzer on Earth right now, it's still an electrochemical sensor, and the accuracy is still the same. And they still degrade in the same manner. If you want higher accuracy on your SO2 sensor, you have to decrease the range of it. That you can do them 0 to 100 versus 0 to 500, and you get a higher resolution. But normally our customers are using these for SF6 switchgear or gas circuit breaker in this case, and they have a limit of 500. So most people go that route because we need to see if it's above the limits or not. Knowing if it's at precisely 35 or 40 parts per million isn't so important. It's below the limit. So most people choose to go with the wider span over the little bit more precision, if you will, but you can get higher precision on those if you go to a lower span. If you want higher accuracy on moisture, you're looking at going over to a chilled mirror, which has a much tighter tolerance and about triple the price tag to go with it. But sometimes you need that. Hopefully that answers those questions about the accuracy. If I missed anything, feel free to hop in with questions as well.
Cool. Justin, is there anything that you feel like I missed as far as the operation goes, or maintaining the device that we should cover? Or
I mean, the only thing I would throw in as far as troubleshooting goes, and in particular with moisture, is always checking all of your physical connections. Like, make sure you didn't test anything like a regulator with a rubber diaphragm, or you didn't put your sweaty mitts on one of the fittings and got them wet. Those are really common issues for people to get a nasty moisture reading, is just from a physical issue versus something wrong with the device. That's just an easy one to watch out for. Um, the other thing to kind of that I would add in on this is what sets our device apart from the Dialo, the Leica. They're all very similar to each other. You can look at them on paper and see that. What sets us apart is the modularity of this device. We designed it to keep it out of our shop. We wanted it at your location so you can use it. That's why it has the modules. That's why there's an access panel for the. You want to show them that, Luke? The maintenance panel for the bag.
Yes. Let me grab a wrench real quick.
So that's a really nice thing we have. So eventually stuff wears out, or if, say you need to replace an inlet sensor, that everything that might need some sort of routine maintenance, if you will, I use that with quotes around it, um, is made to be accessible by the user, so you don't have to send it in. If you mash it up, that's a different story. We'll probably see it for that. But the intention, if you treat it correctly, is that we really don't want to see it at our shop. And that's kind of was our what really went into the design of this product, was talking to everyone that's on this meeting, our customers, and saying, hey, what do you hate about your testers? And calibration was a big one, and having to send the device off. It's expensive. They get damaged in shipping. They're gone for 4, 6, 8, 12 plus weeks. So we tried to eliminate that problem as best we were able to by going over to the sensors. And at some point, you'll see there's 9 squares on there. We are intending to release more modules for the device as well, so you can test other gases and stuff with it. And it looks like some of the mixtures that are coming out, even with uh, CO2 and nitrogen and various things, if that stuff becomes a little more important to people, we'll start adding these on. Or other byproducts, if those need to be tested for, can be added as well. And then, as you can see on this home screen here with those check boxes, you can turn the sensors on and off. If you only need to check moisture, you don't have to check for purity or SO2 or anything else. You just turn them off. So that was kind of our focal point, was making it very easy to use, and also that you're able to see it outside. That's why it has the lovely pastel color palette on there. You can see it in the sun. All I got, bud. Anybody have any
Sorry, I was
other
muted.
questions?
If there is no other questions, if you do have questions, just reach out to us, sales@gasquip.com. If you run into any other kind of stuff related to SF6, we have fittings, hoses, leak detectors, scales, a lot of different stuff. So if you have something that you're dealing with and need help with as far as SF6 gas related goes, reach out to us, call us, all that good stuff, and we'll get back to you on that. And we have these devices in stock and up to a certain amount right now. So if you're looking to buy one, this year, reach out to us. We can even get you a demo over to test it out if you're in the States. And there's no other questions. We can just end it there.
Anybody?
Well, we appreciate all you guys being here today. Really hope that you guys got something out of this. And thanks again. Have a great week.
Thank you, Luke. I want to say outstanding job with the screens, man. That was really, really great. That's so awesome job.
Thanks. I appreciate
Sincerely,
it.
really cool, man.
Appreciate you.
Yeah.
All right, everybody. Have a great week. We'll see you on the next webinar.
Hi, everybody.